Let's see this problem. They have given that RAM access time equal to 1 nanoseconds and hard disk access time equal to 1 milliseconds. Also they have given that we are having single level paging, which means one level page table is used, and they are saying that page fault happens 10% of the times, which means whenever I am accessing the RAM, 10% of the times will result as a page fault. Now they are asking the effective memory access time. See, the reason I have taken this problem is just to understand how to convert nanoseconds to milliseconds and milliseconds to nanoseconds. Okay, I think most of them will be knowing that. Anyway, I'm taking this. Okay, see, you need to understand that 1 second is equal to 10 power 3 milliseconds. Also, 1 second equal to 10 power 6 microseconds. And 1 second equal to 10 power 9 nanoseconds, which means second is larger than millisecond, is larger than microseconds, and it is larger than 1 nanoseconds, right? So 1 nanosecond is the smallest among all of them. So that is why they have given that RAM access time as 1 nanoseconds, which means RAM access time is lesser than hard disk access time, right? This will always be true. See, if this is not true, then why are we actually using the RAM, right? There is no point in using the RAM. Fine. Now how can we convert from one unit to another unit? For example, here it has been given that hard disk access time. Let us assume they have given that we need to compute the effective memory access in nanoseconds, right? They have given that we need to compute the result in nanoseconds. So since we want the answer in nanoseconds, we need to convert everything into nanoseconds, everything which they have given into nanoseconds. They have already given RAM access time in nanoseconds, so we can leave it as it is. Now we need to convert this hard disk access time into nanoseconds, right? Which is in milliseconds. We need to convert it into nanoseconds. How can we do that? See, 1 millisecond. First, what I will do is I will convert it into seconds, right? 1 milliseconds is nothing but 10 power minus 3 seconds, right? See, it is very simple. What do 1 second equal to 10 power 3 millisecond? Now I am going to bring this 10 power 3 over here so that I will be able to get 1 millisecond equal to 10 power minus 3 seconds, right? This 10 power 3 I am moving it here. In that case it will become 10 power minus 3, right? Fine. So I have converted milliseconds into seconds, fine. Now convert the second into nanosecond, because we know that 1 second equal to 10 power 9 nanoseconds, right? So 10 power minus 3 seconds into 10 power minus 3 into 10 power 9 nanoseconds, right? I have converted into nanoseconds by multiplying by 10 power 9. Fine. So now in case if I simplify this, it will become 10 power 9 into 10 power minus 3 is 10 power 6. So 10 power 6 nanosecond is the equivalent form of 1 millisecond. So I can write this as 10 power 6 nanoseconds. Fine. Now it is very straightforward. We can calculate it. See, here nothing is given about TLB, right? Translation look aside buffer is not given. So you can assume that we don't use TLB here. Fine. Again, I'm dividing this effective memory access time into two steps: conversion of logical address into physical address plus accessing the byte. Alright? Fine. Now conversion of logical address to physical address will definitely involve one memory access, right? Irrespective, the page table we will always go into the RAM in order to get the page table. See, there is no TLB, right? See, page tables will always be present in the RAM. Okay, there is no doubt about that. Whether the page is present in the RAM or not, our page table will always be present inside the RAM. Why? See, it is only because of the page table we will be able to understand whether our page is present in the RAM or not, right? We will go into present or absent field in the page table entry, and then we will understand whether the corresponding page is present in the RAM or not. So definitely page table should definitely be present in the RAM. Now conversion of logical address to physical address involves only one memory access. We don't have TLB, so it involves only one memory access, and so it is 1 nanoseconds, right? It is done. Conversion of logical address to physical address will take only 1 nanoseconds. Done. Now accessing the byte. See, coming to accessing the byte, for accessing the byte, it will take 1 nanosecond always. Whether the byte is present in the RAM or not, it will take one RAM access, fine. Now in case of page fault will happen 10% of the times, fine. 10% of the times it is going to take it is going to take an additional 10 power 6 nanoseconds. It is going to take an additional 10 power 6 nanoseconds. So this is the answer. Okay, you can compute it. 1 plus 1 is 2 nanoseconds. Fine. Plus, see, I can make the, I can cancel both the zeros, and I can make this as 10 power 4. Right? I can cancel both of them, and I can make it as 10 power 4. So 10 power 4 into 10 is 10 power 5. Right? So it is 10 power 5 nanoseconds. Now this is nothing but, so 10 power 5 is nothing but 1 followed by 5 zeros, right? 1, 2, 3, 4, and then I'm going to put this 2. So this is the answer. Fine.